Students, in the last class we discussed about VBT, valence bond theory, different types of overlapping, and sigma bond and pi bond. Four different types of hybridization: sp, sp2, sp3, and sp3d. And we discussed the shape of molecules such as methane, boron trifluoride, beryllium difluoride, phosphorus pentachloride, and last ammonia. So in this class we can discuss about the shape of water molecule. Water molecule contain two lone pairs. Ammonia molecule contain one lone pair. So in order to get a clear picture about VBT and hybridization, you watch all videos orderly. Go to YouTube, search Center for Chemistry Kollam. There you can see all videos. You see videos orderly. Chemical bonding 1, chemical bonding 2, 3, and this is the fourth part. Then you will get a clear picture about VBT and shapes of different molecules. Okay, then we can start. H2O. So, what is the shape of a water molecule? 3 more question. Discuss the shape of water molecule. So, H2O, central atom oxygen, and outermost shell 6 electrons. 6 electrons, oxygen atomic number 8, main shell configuration 2, 6. 6 electrons in the outermost shell, hydrogen atom, 1 electron, covalent bond. So this is a water molecule. 2 bond pair and 2 lone pairs. So we can discuss the shape of a water molecule, H2O. This pair, bond pair, lone pair and lone pair. Central atom oxygen, atomic number 8. Electronic configuration 1s2, 2s2, 2p4. And this is the outermost shell, 2s2, 2p4. 4 plus 2, 6 electrons in the valence shell. So ground state electronic configuration. 2s2, 2s2, 2p4, 2px, 2py, 2pz, 2p4, 1, 2, 3, 4, 2p4. And this electronic configuration is called ground state electronic configuration. And in the ground state, oxygen is bivalent, fulfilled, no combining capacity, fulfilled, no combining capacity, half-filled. And valency 2. Oxygen is unable to expand its covalency beyond 4 because of the non-availability of vacant d orbitals. These electrons cannot be excited due to the non-availability of vacant empty d orbitals. So the maximum covalency of oxygen is 2. Oxygen is bivalent, and this is the excited state also. So oxygen ground and excited. So after excited state, this oxygen atom undergo hybridization. So we discussed earlier for different types of molecules. After excitation, the atom undergo hybridization, and this hybridization is sp3 hybridization. sp3 hybridization. And 4 hybrid orbitals are formed. 4 hybrid orbitals are formed, and their orientation, electronic orientation, along the 4 coordinates of a tetrahedron, and 2 orbitals are with lone pair of electrons, two orbitals are with lone pair of electrons and two orbitals are half-filled, and this is the central atom oxygen, and the central atom oxygen contains four hybrid orbitals. Each orbital is called sp3 hybrid orbitals. sp3 hybrid orbitals. Two orbitals carry lone pairs and two orbitals with unpaired electrons over there, half-filled orbitals. And this is the central atom oxygen. Two lone pairs are present in this orbital, and this is the electronic orientation of hybrid orbitals along the four corners of a tetrahedron. Not the shape of water molecule, the orientation of the orbitals, the four orbitals, because the oxygen atom is under sp3 hybridization. Then H atom, two H atom with atomic number 1, configuration 1s1. 1s1 means spherical orbital with one electron, and this hydrogen atom will come and overlap with this sp3 hybrid orbital. Another hydrogen atom overlap in this sp3 hybrid orbital, and thereby the water molecule is produced. So water molecule, so two central atom oxygen and two orbitals, and H atom overlapped here, 2 electrons, and H atom overlapped here, 2 electrons, and H2O is produced, and oxygen also possesses 2 lone pairs, and these are the lone pairs. This is the shape of, this is the structure of water molecule, and two OH bonds are formed by sp3s overlap. sp3s and sp3s, a pair. This pair is called bond pair, and this pair is called bond pair, and these two pairs are lone pairs. So oxygen atom is under sp3 hybridization. So the expected shape tetrahedron, because the electronic orientation is along the four corners of a tetrahedron after sp3 hybridization. So the expected shape is tetrahedron. Expected shape, and the expected bond angle is 109 degree 28 minutes, and this tetrahedron, expected shape tetrahedron, and the expected bond angle 109 degree 28 minutes. But according to VSCPR theory, a lone pair repulsion is strongest. Lone pair repulsion is strongest. So in water molecule, lone pair repulsion takes place, as well as lone pair bond pair repulsion takes place. That is why the bond angle reduced to 104 degree 27 minutes, or simply 104.5 degree. That is the bond angle in water molecule. The expected bond angle is 109 degree 28 minute, but that is reduced to 104 degree 27 minute due to lone pair repulsion. Bond angle reduced to 104.5 degree. And these two orbitals, the lone pairs, orbitals carrying lone pairs has no role on the shape of water molecule. Electronic orientation is along the four corners of a tetrahedron, but in the shape of water molecule, these lone pair orbitals, these two orbitals, lone pairs has no role, and that is why the shape of water molecule is V-shape water, HOH with a bond angle 104.5 degree, and this lone pair has no role on the shape of water molecule. So we can avoid this two lone pair for shape, and the shape becomes V-shape, English letter V-shape. We can write water in this way also, H2O H. So water is V-shape with two lone pairs here, and the shape of water is V-shape with a bond angle 104.5 degree. And the expected shape is tetrahedron, and the actual shape is angular or V-shape due to the presence of two lone pairs. and the bond angle is reduced from 109 degree 28 minute to 104.5 degree due to a lone pair as well as a lone pair bond pair repulsion. And this about water. So water is a V-shaped molecule or angular. So not only water, general H2O type molecules. A is the central atom of oxygen. H2 means the bonded atom, 2 H atoms. AH2 and E2, 2 lone pairs. E stands for the lone pairs, 2 lone pairs. So molecules of this type AH2, E2. So water molecule come under this category AH2, E2. E stands for lone pair, 2 lone pairs, and shape is angular molecule or V-shaped molecule, and bond angle is reduced from hybridization sp3, and bond angle is lesser than 109 degree 28 minute for this type of molecules AH2, E2 due to lone pair as well as a lone pair bond pair repulsion. So AH2, E2 type water come under this class AH2, E2. A stands for the central atom and the other 2 bonded atoms X, and E stands for the unshaded pair, bond pair, and 2 bond pairs, shape angular or V-shaped molecule. It's a bent molecule, and hybridization sp3, expected shape tetrahedron, actual shape V shape, and actual bond angle less than the tetrahedral angle 109 degree 28 minute due to lone pair bond pair repulsion. So another example for H2, E2 is hydrogen sulfide. So S and 2 H atom, sulfur. So 2 lone pairs. This is also AH2, E2 type. Water. So 16th group, oxygen, sulfur, selenium, tellurium, and polonium. So this is water H2O, hydrogen sulfide. Similar molecular species, H2SC, hydrogen selenide, hydrogen telluride, and etc. Polonium is a radioactive substance, we can avoid that. So similar molecular species, all are with the general formula AH2E2, and this is water. So we discussed the water H2O. Water is like this with the 2 lone pairs, and similarly hydrogen selenide, hydrogen telluride, etc. Are with this formula AH2 with the 2 lone pairs, and shape angular or V shape or bent molecule, but oxygen the bond angle is 104.5 degree, but in the case of hydrogen sulfide the bond angle is 92.5 degree. Bond angle is reduced 92.5 degree because oxygen atom is more electronegative, and then by this bond pair of electrons are very closer to oxygen. That is why bond pair repulsion is very high in water compared to hydrogen sulfide. Sulfur is a less electronegative, so a pair of electrons keeps far away from sulfur. That is why bond pair repulsion is less. But here bond pair repulsion is high because oxygen is high electronegative. Pair of electrons in OH bond keeps very nearer to oxygen atom, and thereby bond pair repulsion is high in water, and thereby the bond angle becomes 104.5 degree, but it is reduced to 92.5 because here bond pair repulsion is less because sulfur is less electronegative, so these bond pairs are not very closer to sulfur. So for similar molecular species, when the electronegativity of the central atom decreases, bond angle also decreases. For similar molecular species, when electronegativity of the central atom decreases and bond angle also decreases, shape similar, V shape, bond angle difference, bond angle reduced to 92.5, and in the case of hydrogen cyanide, again bond angle reduced to 91 degree. Selenium hydride, 2 lone pairs, H2E2 type. Similarly, hydrogen telluride also, 2 lone pairs and 2 H atoms. So moving from oxygen to tellurium, electronegativity is decreasing, thereby bond angle is also decreasing, and the bond angle value 91 degree for this molecule, 91 degree, and for 90.5 degree. 90 all are V-shaped. For similar molecules, for similar molecular species, when the electronegativity of the central atom decreases, bond angle also decreases, and shape is same, that is angular V shape. All the molecules come under the class AH2E2. AH2E2. E stands for the unshaped pair. So next, H2O, and this is H2O H2 with 2 lone pairs, and due to the presence of this lone pair, water is acting as a Lewis base. Lewis base, electron pair donor. Electron pair donor is called Lewis base. Ammonia is also a Lewis base. In the last class we discussed about NH3 also. So the presence of lone pair make water a Lewis base, electron pair donor. Electron pair acceptor is called a Lewis acid. So water can act as a Lewis base due to the availability of a lone pair of electrons in the central atom oxygen. So H2O, lone pair, we can take on lone pair, H plus, say Lewis acid. The last class we discussed 1s1, H plus means 1s0, a vacant s orbital with 1 electron. This orbital has a deficiency of 1 electron to become 1s2, and H plus has a deficiency of 2 electron. So this H plus will accept this pair of electrons, and H3O plus is formed. H3O plus, hydronium ion. Hydronium ion. Name hydronium ion, H3O plus, hydronium ion. So H2O, lone pair, 2 lone pairs are there. I take 1 lone pair plus H plus, 2 lone pairs are there, gives OH, hydronium ion, H3O plus, a coordinate bond. Pair of electrons are donated by oxygen, coordinate covalent bond. Pure covalent, and a pair of electrons are donated by one of the atoms for a covalent bond. And oxygen acquire a positive charge due to donation of its electron. This is H3O plus. In H3O plus we can see 2 pure covalent and 1 coordinate covalent bond. Then orbital wise, so this is water molecule, and this is water molecule, oxygen 2 lone pairs, and H plus means a spherical orbital, empty orbital, and that will overlap there. As a result, H3O plus is formed. H3O plus is formed. H3O plus. So this is H3O plus, H, and lone pair again, 1 lone pair again, and a pair. One of the bond is a coordinate bond, and a pair, and this is H3O plus, H3O plus. So this is angular or V-shaped molecule, bent molecule, V-shaped molecule. Oxygen atom is under sp3 hybridization, and the expected shape is tetrahedron. Actual shape is V due to the presence of 2 lone pairs. The expected angle is 109 degree 28 minutes. but actual angle is 104 degree 27 minutes, or roughly 104.5 degree, and when it is changed into hydronium ion H3O plus, central atom oxygen, 3 bond pairs, total 4 orbitals, 3 bond pairs and 1 unshared pair. So the stereochemistry, the shape depends only upon the bond pair, so we can avoid this lone pair. So shape is similar to ammonia NH3, shape trigonal, pyramidal shape, bond angle 107 degree, so H2O V shaped and H3O plus is pyramidal in shape with a bond angle nearly 107 degree, and H2O is a V, and here also oxygen atom is under sp3 hybridization, and the expected shape is tetrahedron. Due to the presence of a lone pair of electrons, it becomes pyramidal, and this is about H2O and H3O plus hydronium ion. Next, so we discussed H2O and H3O plus, a short answer question for 3 marks. What is the shape of water molecule? Discuss the shape of water molecule. And water H2O and H3O plus molecule and ion. So first we can discuss H2O, shortcut method. For 1 mark question, an objective type question. What is the shape of water? What is the shape of H2O molecule? Any other molecule? So we can calculate the number of hybrid orbitals by steric number or Sn is equal to total number of hybrid orbitals around central atom. Total number of hybrid orbitals around the central atom, or total number of atoms or groups and lone pair of electrons. This is steric number. This is simple. Total number of hybrid orbitals around the central atom, or total number of atoms or groups and lone pair of electrons around the central atom is called steric number Sn. So we can, the shortcut way to identify the hybridization and shape. Okay, H2O molecule. So steric number is equal to, this is the equation, half into V plus M minus C plus A. This is the formula. V plus M minus C plus A. So V means total number of valence electrons in the central atom. Total number of valence electrons in the central atom. V is equal to valence electrons. V stands for valence. Valence electrons in the central atom. In water, central atom is oxygen. In methane, the central atom is carbon. And M is equal to monovalent atoms. Monovalent atoms present in central atom. Present in the central atom. And C summum charge on the cation. Charge of the cation. If it is a cation, NH4 plus is a cation, H3O plus is a cation, charge of the cation. And A summum charge on the anion. This is the formula. V plus M minus C plus A divided by 2. So we can calculate the steric number of water, and we can identify, we can the number of hybrid orbitals, and then we can find out the shape of water molecule there. Okay, this is the formula. So steric number Sn is equal to half into V plus M minus C plus A. So H2O molecule. H2O. HOH. Central atom oxygen. Oxygen belongs to 16th group. Oxygen, sulfur, selenium, tellurium, polonium all possess 6 electrons in the valence shell. 6 electrons. Oxygen possesses 6 electrons in the valence shell. So Sn is equal to steric number is equal to half into 6 plus monovalent atom bonded to central atom. 2 monovalent atom, 2 H atoms plus 2. These are not applicable because this is a neutral molecule. Minus 0 plus 0. So 6 plus 2 8. 8 by 2 is equal to 4. Is equal to 4. Therefore steric number is equal to 4. That means the total number of hybrid orbitals around oxygen is equal to 4. So these are the orbitals S and Px, Py, S orbital and P orbitals and 5 D orbitals. 1, 2, 3, 4 and 5. S, P, D. Steric number 4. 4 means 1, 2, 3, 4. So hybridization sp3. So in water, central atom oxygen is under which hybridization? sp3 hybridization. So hybridization sp3. sp3 means 4 hybrid orbitals. 4 hybrid orbitals. Here 2 orbitals are bond pairs. 2 orbitals BP. Total 4 orbitals. That means 2 LPs. 2 lone pair in water. Total orbitals 4. From this structure we can there see 2 bond pairs. So 2 bond pair and 2 lone pairs. So that about water. Then again structure oxygen. OH 2 bond pair and 2 lone pair. So type AH2E2 type. So shape and angular or V shape. Bond angle 104.5 degree due to lone pair repulsion. This is the shortcut, simple way to identify hybridization. And water molecule come under AH2E2. Total orbitals 4. 2 orbitals for bond pair, and where the 2 other orbitals they carry lone pairs. So we divide the 4 orbitals into 2 categories. 2 for bond pair and the remaining 2 for lone pairs. So formula AH2E2. AH2E2 type are V shape. Bond angle less than 109 degree, 28 minutes due to lone pair as well as a lone pair bond pair repulsion. This about water. So we can take hydronium ion. Take hydronium ion H3O plus. We can calculate the steric number. Hydronium ion H3O plus. Hydronium ion H3O plus. Steric number Sn is equal to half into number of valence electrons in the central atom oxygen. Oxygen is 16th group or 6 electrons for all 16th group elements, and monovalent atoms connected to central atom for 3 H atoms plus 3 minus cationic charge. So plus 1, so minus 1 positive charge. Sodium, atomic number 11, 281. It is changed into Na plus. It loses 1 electron, 28. So total number of electrons in sodium 11. In Na plus it is 10. So it is carrying a positive charge. So subtract 1. So minus cationic charge. So this is not applicable for only for anions 0. So a positive charge minus 1. Na changed into Na plus. Na 11 electrons. Na plus 1 electrons. So 11 minus 1 is equal to 10. So number of electrons present in Na is equal to 10. Similarly, the H3O plus carrying a positive charge. So subtract 1 electron and cationic charge is plus 1. So therefore half into 6 plus 3, 9, 9 minus 1, 8. So is equal to 4. 4 hybrid orbitals. 4 hybrid orbitals. Out of 4 hybrid orbitals, 3 bond pairs. Oxygen carry 3 H atoms. 3 bond pairs. 3 BP. Total 4 plus 1 lone pair. So we can split this 4 into 3 for 3 bond pair and 1 lone pair. So hydronium ion carry 3 bond pair and 1 lone pair. So structure oxygen 3 bond pair, 3H and 1 lone pair and carrying a positive charge. So shape pyramidal. Shape pyramidal. Lone pair has no role on the shape of the molecule. And 3 bond pair. Bond angle 107 degree. Shape pyramidal. Pyramidal. This is the shortcut. This is the shortcut for determining hybridization and shape. So one more example. In the next class we can discuss more molecules with this shortcut formula and methane CH4. So steric number is equal to half into V plus M minus C plus A. So this is a neutral molecule. So central atom carbon, 14th group element. So steric number is equal to half into. So 14th group element possesses 4 electron in the valence shell plus monovalent atom. So 4 hydrogen atom, monovalent atom 4. This is a neutral molecule, minus 0 plus 0. Not applicable. So 8 by 2 is equal to 4. 4 hybrid orbitals. Around the carbon 4 H atoms. 4 hybrid orbital also. So S, P3 and 5D. So hybridization 4 orbital. 1, 2, 3, 4. Hybridization sp3. 4 hybrid orbitals. No lone pair. So 4 bond pairs. CH4. 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 Hybridization hybrid orbitals 4 and 4 bond pairs also. This is carbon. 4 bond pairs. And this is a AX4 type molecule. No lone pair. And the H atom here. Tetrahedron. Bond angle 109 degree 28 minutes. And this is type AX4 with no lone pair. All AX4 tetrahedron. Bond angle 109 degree 28 minutes. AX4 type. AX4 type. AX4 type is a tetrahedron. Bond angle 109 degree 28 minutes. And this is about NH3 and NH4 plus. Thank you very much.